We're going to talk about balancing redox reactions, and this can be difficult because not only are you trying to balance out atoms, but you're trying to balance out charges. You want to start off by writing the two individual half reactions, the oxidation and the reduction half reaction. You want to then balance out all elements except oxygen and hydrogen, then balance the oxygen atoms by adding H2O molecules, and then balance the hydrogen atoms by adding H+ ions. Balance the charges by adding electrons, and if necessary, multiply each half reaction's coefficients by the smallest possible integers to yield an equal number of electrons in each half reaction, because what you're trying to do is cancel those electrons out. Add the balanced half reactions together and then cancel anything that appears on both sides of the equation. For reactions occurring in basic solution, there's a few more steps. You have to add OH- ions to both sides of the equation in numbers equal to the number of H+ ions that you just added. And on the side of the equation containing both H+ and OH-, you want to combine to yield H2O molecules, and then simplify by reducing the H2O molecules. Finally, check to see that the number of atoms and the total charges are balanced. Let's take a look at an example. In acidic solution, Cr2O72- reacts with HNO2 to yield Cr3+ and NO3-. Write a balanced equation for this reaction. You want to start off with your given. And then you want to come up with half reactions that have a common element on both sides of the equation. So in my first half reaction, chromium is the common element. In the second half reaction, nitrogen is the common element. First thing you want to do is balance all elements except oxygen and hydrogen. I have 2 chromiums on the left, so I need 2 chromiums on the right. There is only 1 nitrogen on both sides in the second half reaction, so I don't need to do anything there. So I'm going to go ahead and clean up. Now I want to balance out my oxygens. In my first half reaction, I have 7 oxygens on the left, so I have to add 7 H2O on the right. In my second half reaction, I have 2 oxygens on the left and 3 on the right, so I'm going to add 1 H2O. 1 oxygen plus 2 oxygens equals 3 oxygens. Okay, I want to clean that up. After I balance out my oxygens, I want to balance out my hydrogens. In my first half reaction, I have 7 times 2 is 14, so I have 14 hydrogens on the right side, so I want to add 14 on the left side. In my second half reaction, I have 2 plus 1 is 3 hydrogens, so I want to add 3 hydrogens on my right. I want to clean that up. Now I want to balance out my charges. On my left side on the first half reaction, I have 14 plus a -2, so the charge is 12, versus on the right side, I have 2 times 3 is 6. I have a positive 6 on the right. I can only balance charges by adding electrons, so I'm going to have to add 6 electrons on the left. Remember, electrons are negative, so that would give me a charge of 6 and versus a charge of 6. In my second half reaction, I have a total charge of 0 on the left, and on the right, a -1 plus a +3 is a +2. So I need to add 2 electrons being negative on the right. So my charges balance out. Now the goal is to get the charges to cancel out. I have 6 electrons in the first half reaction. I only have 2 on the second half reaction. So I'm going to go ahead and multiply 3 on the second half reaction. So let's go ahead and do a cleanup here. And I'm going to distribute the 3 to every part of that equation. Three times 3 is 9, and 3 times 2 is 6. All right, so now it's time for just a final cleanup. Whatever appears on both sides, we have to cancel. So 6 electrons cancels out with 6 electrons. These 3 waters will cancel out and be left with 4. 9 H pluses can cancel out with some of these, and this will leave me with 5. So my final clean up equation that's a L. That's L for liquid. So final answer, I have my elements balanced out, my charges, and my phases. Let's take a look at another example. In basic solution, Cl2 reacts with OH minus to yield Cl minus and ClO3 minus. Write a balanced equation for this reaction. I want to start off with my given. And I want to remind myself that this is basic solution. So I want to come up with 2 half reactions. In my first half reaction, chlorine is the common element. In my second half reaction, oxygen is my common element. So I'm going to balance out my elements except oxygen and hydrogen. In my first reaction, I have 2 chlorines on the left, so I'm going to put 2 chlorines on the right. In my second half reaction, we're just balancing elements, oxygen and hydrogen later on. I have no chlorines on the left, and I have 1 chlorine on the right. So I'm going to have to add a Cl minus. Let's do a cleanup. The next thing we want to do is balance out the oxygens. In the first half reaction, we don't have any oxygens. In the second half reactions, there is 1 oxygen on the left, 3 on the right. So I have to add 2 waters. So I've got 2 oxygens here. 2 times 1 is 2, plus this one will give me 3. So let's go ahead and do a cleanup here. The next thing we want to do is add or balance out our hydrogens. The first equation doesn't have any hydrogens. Let's take a look at the second. The second has 2 times 2 is 4, plus this one is 5. So I need 5 H pluses. Now, this is a basic solution, so I'm going to have to add as many OH minuses as there are H pluses on both sides of the equation. So 5 OH minuses, 5 OH minuses. Okay, let's do a cleanup here. I want to start combining a couple things. Just to keep things organized, I have 5 OH minus plus this 1 OH minus. So I'm going to go ahead and write that down together. And I also have 5 H pluses and 5 OH minuses. That makes 5 H2O. Now I want to go ahead and look at my charges. I have a total of 0 charge on the left and a -2 on the right in my first half reaction. So I'm going to have to add 2 electrons. And let's take a look at my second half reaction. I have a total of -7 on the left versus -1 on the right. So I'm going to have to add 6 electrons on the right there. Let's go ahead and clean this up. Now we got to look at our electrons. Our goal is to try to cancel. There are 2 electrons in the first equation, 6 in the second. So let's go ahead and multiply by 3 in the first equation. So I'm going to distribute the 3. And in the second equation, all right, we can start looking for things to cancel out. The 6 can cancel with the 6. One of these chlorines can cancel with 1 here, leaves me with 5. And these 2 waters can cancel and give me 3 on the right. I think that's all we have. So let's go ahead and write down our cleanup. Final answer. Our elements are balanced out, our charges are balanced out, and our phases are shown, aqueous and liquid. Good luck and keep practicing.